Howdy students, this is a video on dimensional analysis, which is experience zero, something that we have implemented into the curriculum that we feel you would need in order to be prepared for the following experiences. So, with that said, let's begin. Take a look at the image below. Let's see if you can find some kind of pattern here. We see that the red circle shows up twice, so does the yellow square and the blue triangle and the green pentagon and the orange star. Now, you'll see an equal sign at the right side of this image. Well, if we start with a red circle on the left and we end up with the green star, the orange star, something happened in the middle in order for us to do that. Well, let's look. If we take the red circle and we change it into a yellow square, then we can take the yellow square and turn it into a blue triangle. And then we take the blue triangle and we turn it into a green pentagon. And then finally, the green pentagon turns into a orange star. Quite simply, this is called dimensional analysis. In chemistry, we're going to use this process to determine how to change one unit into another unit, such as feet into miles. In chemistry, perhaps we're looking at atoms into mass in grams. So let's define what dimensional analysis is. It is something that we need to express a measurement in a different unit than the one that was initially used. Dimensional analysis is a way to analyze and solve problems by using the units, or what we call dimensions, of the measurement. This could be length, time, volume, mass, quantity, etc. In order to complete dimensional analysis, we need something called a conversion factor. To convert one unit into another one, we need a conversion factor. Conversion factors are equalities that are arranged as ratios or fractions with different units. For every equality or ratio, there are two ways that we can write it. So here's an example. We know that if we have $1, that equates to 4 quarters. So here written looks the exact same, but you'll notice that $1 is on the top and then 4 quarters is on the bottom on the left side. And on the right side, you have 4 quarters on top and $1 on bottom. So for us in chemistry, this is important because if we're turning one unit into another, it matters which one is on top. So we're going to be completing some metric conversions today, and then we'll get into some other units. Metric conversions are units that are used around the world, and typically they allow us to quickly go from one unit into another simply by adding a prefix. So you've probably heard of a lot of these before, such as liter versus milliliter, or perhaps meter versus kilometer or a kilometer. And what we're going to do is be able to pull out what we call conversion factors in order to complete our dimensional analysis. So let's look at this metric conversion. You should have a copy with you while we do this. And the mnemonic we use is called King Henry died unusually drinking chocolate milk. So let's break that down. King stands for kilo, that's the prefix kilo. Henry stands for hecta. Died is for deca, and typically those are capital letters. Unusually is going to be our base unit column. Okay, this is important. So unusually is for base unit. Well, the base unit can be multiple things. There are 7 base units. We have meters, liters, grams. We're going to learn about more, such as time, the mole, candelas, amperes for current. There are others as well. Drinking would be for deci, and then chocolate would be for centi. Milk would be for milli. And so what you need to know is that each column, each vertical column up and down, if we go left to right, every time we jump or move one column to another, it changes by a factor of 10. This is the beauty of the metric system. Everything is by tens. So if we start with our base unit in the center, such as the meter, if we go one space to the right, that becomes a decimeter, and that's 10 times smaller. Well, if we go to the left from the base unit meter, it becomes a decameter, which is 10 times larger than that unit. Okay, so a decameter can fit 10 smaller meters within it. Now, a decimeter, okay, you can fit 10 decimeters into 1 meter. Now, what if we're jumping from decimeters to decameters? Okay, well, that's 2 jumps, and that would be not 10, but 100. So there are 100 decimeters in every decameter. Okay, so if you went from king to milk, that's a difference of 6 jumps, and that is 1 million, 10 to the 6th. Okay, 6 zeros. So 1 million millimeters in a kilometer or kilometer. So let's go ahead and jump into our conversions. Here's some examples that we can pull from that chart with King Henry. Here's the first one. If we jump twice from a meter to a centimeter, 2 jumps, that's 100. So you got to make sure you can write it correctly. 1 meter equates to 100 centimeters. Likewise, you could write it upside down, and you could say that 100 centimeters is 1 meter. Conversion factor for meter and kilometers. Here's another popular one. In 1 kilometer, there are 1,000 meters. That's 3 jumps. 3 jumps on King Henry's chart. And then let's do another one. How about liters and milliliters? If we start with the base unit liters and go to milliliters, that's also 3 jumps. Okay, but 1 liter will be able to fit 1,000 smaller milliliters into it. So how are we actually going to convert these? Let's do one more here from centigrams to milligrams. We're staying on the right side of the chart. 1 centigram, that's jumping 1 place to milligrams. Milligrams are smaller, so that's 10 milligrams for every centigram. So when we're computing these problems, we have to learn a process that we're all doing the same way so that it helps us understand. Yes, there are other ways of doing this. We're going to teach you one in this class. So the steps to dimensional analysis are this. Step 1, identify the conversion factors that you can use or that you have at your disposal. Number 2, we're going to set up the conversion factors so that the units that you do not want to have in your answer will cancel. Typically, these have to be on top and bottom in order to cancel out with one another. Then what we're going to do is multiply by the correct conversion factor, and we're going to multiply numbers on the top and divide numbers on the bottom. We'll work on this together. So to do this, we're going to use what we call T-charts. Top right, you see an example of a T-chart. Some people call them train tracks. It's also been called factor label method. There are many ways of saying it. We're going to draw out a T-chart and organize the information. Okay, we have to show work to keep track of our thoughts. We're going to write what we're given in the top left corner of the T-chart. Typically, there won't be anything on the far left bottom, but sometimes there can be. We're going to bring the units down and to the right. We're going to say this a lot, down and to the right, down and to the right, because that's how we're going to cancel out the units as we go. The units will cross out or cancel diagonally, down and to the right. We're going to use as many conversion factors that we need to get to the correct answer. The units of our final answer should be in the top right corner of our T-chart. Okay, all that to say, let's practice. How many inches are there in 4 feet? And you're thinking to yourself, okay, 4 feet, I know that it's 48 inches, right? You could probably do that in your head. But let's think about what we had to know in order to figure that out. We needed to know that for every 1 foot, that equates to 12 inches. We need a conversion factor. So let's show it in a T-table. Write this out. 4.0 feet is going to go in our top left box or portion of the T-chart or train tracks. There's not going to be anything underneath the 4 in this problem. We're going to place our conversion factor so that feet cancel down and to the right. So down and to the right, we're going to put 1 foot, because that's what my conversion factor says, and then 12 inches will go on top. And in this case, the feet will cancel, and the 12 inches will remain. So how do we calculate? Well, you're going to multiply everything on the top together, get an answer, and you're going to divide by everything that is multiplied on the bottom, which is just 1 in this case. So that equates to 48 inches. This is how we convert units. Let's do another one. Let's come from the metric chart and do 70 kilograms, and we're going to turn that into grams. Okay, so we're going to start by putting 70 kilograms in our top left part of the box, nothing underneath. From the chart, I know that a kilogram is 1,000 times bigger than a base unit gram. It's a jump of 3. 1, 2, 3 jumps. So for every 1 large kilogram, that's going to be 1,000 smaller grams. So I'm essentially doing 70 times 1,000 here. And the answer would be 70,000 grams. Let's do another one. 2.5 liters. Maybe pause here if you want to work this one on your own. 2.5 liters equals X milliliters. So the base unit is liters. We're going to set up a t-table and put 2.5 liters into the top left part of the box. For every 1 liter, we're going to milli, which is also a jump of 3. 1, 2, 3. So that's 10 times 10 times 10, which is 1,000. So 1 liter can fit 1,000 milliliters, lowercase m there. To calculate, multiply everything on the top together, get an answer, and then we're going to divide by everything on the bottom multiplied together, which in this case is just 1, so we get 2,500 milliliters. Okay, pause and maybe complete 3, 4, and 5 on your own. Not all of these are metric units, but these are common conversions that you should know. Okay, hopefully you've paused the video. Let's work through these. So we're going to take 9.54 kilograms from King Henry's chart. We can take 1 kilogram and convert to 1,000 grams. When we multiply, we get 9,540 grams. For number 4, we go feet to inches. We're going to start with 3.54 feet in the top left. 1 foot is 12 inches. We multiply together, divide by 1, we get 42.5 inches. And last but not least, 40 minutes. And let me just say one thing real quick. You need to be writing this out in the T-chart because that's the way we're computing. When we get into really complex formulas and problems, we need to make sure that we're doing the T-chart properly or we're going to mess up our problems. 40 minutes, 1 minute on the bottom, and 60 seconds on top. Now, also to mention, there has been a 1 on the bottom of all of these problems. It does not have to be 1. Final answer, 2,400 seconds. Okay, how about some real-world examples? Okay, let's get a little more complex. Feel free to pause if you want to try these on your own at first and then see how we work them. How many seconds are in 5.7 hours? 1 hour equals 3,600 seconds. We gave you a shortcut here, so you didn't have to do multiple steps. 5.7 hours top left, down and to the right, we're going to put our 1 hour, and on the top, 3,600 seconds. Multiply 5.7 by 3,600, we get 20,520 seconds. Number 2, how many students are in a 10-room building if each classroom contains 25 students? Students often get stuck here because they don't know where to start. How many students are in a 10-room building if each classroom contains 25 students? So, if you start with 25 students, what's important is that you attach 1 classroom with it, right? That's the conversion factor. 1 classroom equals 25 students. So in this case, we're going to start with 10 rooms because 10 rooms isn't a conversion factor. Typically, we don't start with conversion factors. Our conversion factor that we do have is each room, so 1 room contains 25 students. 10 times 25 divided by 1 is 250 students. Number 3, a little more complex. How many atoms are in 7 grams of gold? We give you the conversion that 1 atom of gold is 3.271 times 10 to the power raised the exponent, negative 22 grams. So let's work out our t-table. Don't be afraid. 7 grams of gold, which is AU. Our conversion factor says that 3.271 times 10 to the negative 22nd grams equals 1 atom of gold. So we calculate, and we get 2.14 times 10 to the 22nd atoms of gold. Number 4, how many liters are in 360 milliliters of solution? So this is a King Henry metric conversion. We see the prefix milli. We're going to start with 360 milliliters. And from King Henry, that's a jump of 3, 1,000. What's important is to know that there's 1,000 smaller milliliters in every 1 liter. So check it out. We don't have a 1 on the bottom. We have 1,000. So we're going to be doing 360 times 1 divided by 1,000. Final answer is 0.36 liters. Now, take a break if you want to before this next part, but we're going to look at multi-step problems. What if we need more than one conversion factor? So let's start and do how many seconds are in 5.0 days. So you may not know how many steps it's going to take, so feel free to just draw the T-chart out with one vertical line first and add as you go. So let's start with 5 days. Some of y'all know exactly how to do this problem already, but let's use our T-chart. 1 day is 24 hours, right? Because I don't know how many seconds are in a day. Maybe some of you do. But I know that 1 day is 24 hours. And I know that 1 hour, there's 60 minutes. And I know that in 1 minute, there are 60 seconds. Days cancels, hours cancels, minutes cancels. We're left with seconds. So how do I calculate? It would be 5 times 24 times 60 times 60. And then I'm going to take that top number and I'm going to divide by everything multiplied on the bottom. So 1 times 1 times 1, which is 1. Final answer, 430,000 seconds. How many centigrams are in 9.54 kilograms? So from the chart, you might be able to do this in one step, but sometimes I like to break it into 2 steps. Check it out. 9.54 kilograms. I know that there is 1,000 grams in a big kilogram. So 1 kilogram contains 1,000 grams. I'm jumping to the center of my chart. Then I know that in every 1 gram, there's 100 centigrams. So I broke it up into 2 steps. That's also possible. 9.54 times 1,000 times 100 on top, divide by everything on bottom, which is just 1. 954,000 centigrams. Okay, this one may take a while. I would pause and give it a shot. How many broad jumps would it take for you to jump to Disney World from here? So a broad jump is when you stand with your 2 feet and thrust your arms and jump with both feet at the same time and land with both feet at the same time. So we give you some conversion factors from CSHS to Orlando. That's 1,052 miles. We also give you that 1 inch is 2.54 centimeters. We give you the conversion from feet to miles and centimeters to broad jumps. So your broad jump may be a little bit different, but on average, it's about 134 centimeters. So T-table. Again, you may not know how many steps it's going to take. This slide has them all listed out. Let's start with 1,052 miles. So we're going to start with the distance. If you don't, it's okay. As long as you make sure that all of your units cancel properly, you can start in different places. We're going to start with distance, though, because we need to know how many jumps it takes to get from one place to another. So my first conversion factor, I'm going to use the miles to feet. So 1 mile is 5,280 feet, straight from the problem. The next thing I have is inches to centimeters, but I don't have the conversion from feet to inches. Well, we didn't give it to you because we expect you to know that in 1 foot, there's 12 inches. Some things we may not give you because we expect you to know those things. 1 inch is 2.54 centimeters. And then, on average, 134 centimeters is 1 broad jump. So if we calculate, here's how I would do it. 1,052 times 5,280 times 12 times 2.54 centimeters times 1. All that on top. And then on bottom, I would do 1 times 1 times 1 times 134. And then I would divide the top by the bottom number. Final answer is, looks like 1,260,000 jumps, or 1.26 times 10 to the 6th jumps.